So welcome dreamers. I hope so my voice is clear. Right, Kiran Kumar and Parth Patel. Good evening everyone. Let me check that whether my voice and everything is clear. I hope so my voice is clear and everything is fantastic. My PPT is visible. Kiran and Parth, welcome back to the session. Let's welcome all the participants right now so that we'll start the party. Let's begin the party. This is Ravindra Thube, faculty at BYJU'S Exam Prep, and you're watching the BYJU'S Exam Prep dedicated mechanical and civil channel where Hindi and English sessions are being conducted. So welcome aboard. Welcome participants. We have today a simple thing because you know that metal cutting is ocean. Right, Parth Patel, this is not quick revision, this is in English, so that it's a 60-mark series and there are 5 sessions are conducted or 5 sessions are scheduled as far as production is concerned. Right, Naseem Khan, yes, good evening. How many sessions are being scheduled? There are 5 sessions are scheduled. Each session, each day will be taking one topic where some important questions will be discussed, where some theoretical background will be also discussed. And the demand of the students is that please discuss the questions so that we are having questions where a number of revisions will be taken care. Everybody, right? Fine. So I think so we'll start discussing the problems, start discussing certain theory. Please point to be understand that metal cutting is an ocean of knowledge. It is a very vast subject and each and every numerical is very difficult to solve in one particular hour of session. So that here I try to cover some basic fundamental questions related to a basic orthogonal machining operation. Basic orthogonal machining operation where maximum number of questions are coming. Because whenever we are dividing this entire topic of metal cutting, there are 3 verticals where questions are being asked. One is nothing but a ESE and ORS system of tool geometry. Maximum questions are coming based on a orthogonal machining process where the force analysis, Merchant's analysis for force, minimum energy, power, and that energy consumption comes in the picture, right? And after that there is the economics of machining and tool life. So these are the verticals. Recently there are certain questions are also asked based on a influence of metal cutting on or influence of tool geometry on the surface finish. Is it okay everyone? Yes. So we are starting now the session quickly, right? So let's say that, and I told you that we have selected, super excited, yes, we have selected the questions, not too much very hard and not too much, so optimized questions are selected where we'll get idea of fundamental questions also. Is it okay everyone? Yes. So I look beautiful on the screen, right? I think so. So we'll kick start. Let's the party begin, right? Every participant is ready, right? Fine. So let's begin the question number first. Simple questions we'll begin with and then we'll go and increase the level of questions where number of things will be unfolded. Right, fine. So here is the question number first. In an orthogonal cutting operation, orthogonal cutting operation, the cutting velocity is 40 meter per minute and the chip velocity is 20 meter per minute. If the rake angle of the tool is 10 degree, what is exactly shear angle is? I hope so you're all ready at this particular point. You're all ready at this particular point. Is it okay? Just a minute. Hello? क्लास सुरू झाला पटकन बोल काय कॅन्सल फाईन Is it okay everyone? Yes. Is it okay everyone? Yes. Now I'll say that sir, whenever we are interested to calculate option A, yes, Utkarsh and a lot of participants have joined. Let's say that Tamatar Singh is also joined after so many days. Shear angle. So if I'm interested to calculate shear angle, I'll say that sir, data we have to write. Everybody knows that sir, cutting velocity is given. I'll write on VC is exactly equal to 40 meter per minute. 40 meter per minute. Right, fine. Chip velocity VF is exactly equal to, what is it? Chip velocity VF is exactly equal to 20 meter per minute. Right, fine. This is just the beginning of the question. And the shear angle is given 10 degree. So I'll say that shear angle phi is exactly 10 degree. Right, fine. So if I'm interested to calculate, sorry, shear angle is not given, rake angle is given, I'm sorry. So rake angle is given, that is orthogonal rake angle alpha 0 is given 10 degree. So now we know that sir, if I'm interested to calculate a shear plane angle, that is angle made by shear plane with cutting velocity vector, there is equa is coming, we'll sort it out in the next session. So when we are interested to calculate angle made by shear plane with cutting velocity vector, we have a different formula or important formula. What is that? Sir, tan phi is exactly equal to R into cos of alpha 0. R into what? Cos of alpha 0 divided by R into sin of alpha 0. Divided by, sorry, 1 minus R into sin of alpha 0. Is it okay? Yes. So we required orthogonal rectangle and we required chip thickness ratio. Now sir, chip thickness ratio can be calculated by simply, can I say that VF divided by VC? VF by VC chip thickness ratio can be calculated, and we know that what is VF value? So VF value is exactly 20 meter per minute divided by VC, cutting velocity is 40 meter per minute, chip thickness ratio is coming 0.5. So you put the 0.5 value there. So I'll say that sir, tan phi is exactly equal to, very simple basic question, 0.5 into cos of alpha 0, that is cos of 10 degree. Is it okay everybody? Cos of what? A 10 degree divided by 1 minus 0.5 into a sine of 10 degree. So how much answer is coming? We know that chip thickness ratio phi is coming exactly to 28.33 degree. 28 point what? 33 degrees. So this is exactly equal to a phi value is coming 28.33 degree. So if I come back and we'll say that sir, my answer is exactly equal to, this is my answer. I hope so everybody has calculated. Yet Utkarsh, Naseem and everybody, Tamatar Singh, everybody has calculated correct answer. No worries at all. Right? Quickly we'll go to the next question. Right? This is linked as a question. Calculate shear velocity. This is also very famous question in GATE examination. Calculate shear velocity with the help of velocity triangle. Let's understand now velocity triangle. We know that this is the orthogonal view of metal cutting operation. This is orthogonal view of metal cutting operation. So can I say that sir, angle made by shear plane with cutting velocity vector is nothing but shear plane angle phi. It is nothing but what? Shear plane angle phi, because we know that sir, this is exactly equal to a cutting velocity vector. Can I say that this is the direction in which cutting velocity vector is acting? So this is exactly equal to VC. And shearing takes place along the shear plane. So along the shear plane, which velocity? Shear velocity. So therefore along that, this is shear velocity, Vs is acting, and chip is flowing over the rake surface. So I'll say that sir, this is nothing but chip velocity Vf. So this is nothing but chip velocity Vf comes in the picture. Vf comes in the picture. Angle made by shear plane with cutting velocity vector is shear plane angle phi. Okay, fine. Now sir, if I draw the vertical line, everybody knows that sir, what is the vertical line angle? This is nothing but, I'll say that sir, this angle is nothing but orthogonal rectangle alpha 0. Is it orthogonal rectangle alpha 0? Yes, orthogonal rectangle. If this is alpha 0, I'll say that this will be also exactly equal to alpha 0. This is 90 degree. So this angle will be exactly equal to 90 minus alpha 0. Isn't it everybody? 90 minus alpha 0. Now we are interested to calculate total angle of this particular velocity triangle. Everywhere we have to use this velocity triangle. So how much will be this angle? It will be 180 minus phi minus 90 minus alpha 0. If I say that this will be a star angle, so I'll say that this will be coming as 90 minus phi minus alpha 0. 90 minus phi minus alpha 0. Is it coming? 90 minus phi minus alpha 0? Yes. Now with this velocity triangle, we have to calculate what? Shear plane velocity Vf. Vf we have to calculate. Now can we set the relation between the Vf with respect to Vs and Vc? We can do the relation between them, right? Fine. So you have any choice. I'll do one thing, that Vs is nothing but a shear plane velocity. If I take shear plane velocity Vs, what is the opposite of angle of this? 90 minus alpha 0. Sine of 90 minus alpha 0. What is coming? Cos of alpha 0 is exactly equal to, we are interested to calculate what? Vs. Okay, Vs is already considered. So you can take Vf or we can take Vc. If I take Vc, opposite is 90 minus phi minus alpha 0. It will come cos of phi minus alpha 0. I'm taking what? Vf. Opposite that is what exactly sine phi. Right, fine. So alpha value we know that, alpha 0 value we know that, alpha 0 value we know that 10 degrees. Vf value, chip flow velocity, it is also known to us. Chip flow velocity is known to us, right? Phi value just now we have calculated. So you tell me that what is the shear plane velocity? What is the shear plane velocity is coming? And most of the students are telling del D is correct answer. And if I go and talk about del D, can I say that 41 meter per minute? So this is what exactly my answer is, 41 meter per minute. Is it okay? Simple fundamental, 41 meter per minute. Roughly this value is coming. Is it understood everyone? Yes, this is what exactly my answer is. Very important as far as GATE examination is concerned, because you need to understand that whenever sir isko Lamis, yes, Lamis theorem bhi bolte, it is velocity triangle, and we can got it right. I got the same, right? Fine, no issues. Okay, next question. Let's see how beautiful this question is. A single point right-handed turning tool is used for a straight turning, right? Straight turning operation. The speed is 0.25 mm per revolution and the uncut chip thickness is found to be 0.25, the inclination angle of the main cutting edge is 10 degree, the backrake angle of this tool is. And so many times, Kiran Kumar, this question I had already taken in the class or somewhere in the open platform also. So you should tell me that. So that this is just a revision for you. Okay, what exactly equal 10 degree, Kiran Kumar? I hope so your memory is very sharp, right? Your understanding 10 degrees coming. It's very simple that, sir, feed value is given and feed value is given 0.25 mm per revolution, right? Feed is given and it was given that uncut chip thickness, that is T naught. T naught is given 0.25. If you understand that, can I say uncut chip thickness T naught becomes exactly equal to feed value? Uncut chip thickness T naught becomes exactly equal to feed value, or we can say that my feed value becomes exactly equal to uncut chip thickness. And when does it happen? When the feed value becomes uncut chip thickness. If you know real metal cutting operation, you'll know that, sir, uncut chip thickness will become exactly equal, or feed will become uncut chip thickness when approach angle lambda has to be 90 degree, or can I say that side cutting edge CS is exactly 0 degree. In such case, can I say that the feed becomes uncut chip thickness? Undoubtedly. And if I draw this figure, in this figure you can understand what is the approach angle lambda. Lambda is exactly 90 degree. What is the side cutting edge angle CS? CS is exactly 0 degree. CS is exactly 0 degree. So therefore, can I say that what is a cutting plane? So can I say that cutting plane is the plane which is parallel to cutting edge. So can I say this will be exactly equal to my cutting plane pi c. Cutting plane pi c. What will be orthogonal plane? Orthogonal plane is normal to cutting edge. So can I say that I'll draw here roughly. So this will be my orthogonal plane pi o. This will be my orthogonal plane pi o. Right? What will be a transverse plane and what will be a machine longitudinal plane? Machine longitudinal plane. So can I say that machine longitudinal plane will be coinciding to the orthogonal plane, that is nothing but called as pi x, and machine transverse plane will be coinciding. Can I say that it will be coinciding to the cutting plane, that is pi y? This pi x and the pi y, this pi x and the pi y plane are for what? ESE system of tool geometry. And can I say that in orthogonal rake system tool geometry, can I say it will be exactly orthogonal rake and the cutting plane, orthogonal rake and the cutting plane, not basically these particular, not equal. I'll say that, sir, these particular planes are related to this. Here can I say that orthogonal plane, where is the orthogonal plane? This orthogonal plane is coinciding to the machine longitudinal plane and cutting plane is coinciding to the transverse plane. So can I say that ESE and ORS system of tool geometry become same? So can I say that, sir, my backrake angle alpha B will become exactly equal to inclination angle I? Can I say that backrake angle alpha B becomes exactly equal to inclination angle I? Isn't it so? Yes, absolutely true. So therefore can I say that, sir, what is given here? Sir, it is given here the inclination angle of the main cutting edge is 10 degree. So what will be backrake angle? So can I say that I is exactly equal to alpha B, that is exactly equal to 10 degree. Basic fundamental. I hope you are understanding this. Is it okay, everybody? Naseem, Rajit Sharma? Yes? Yes? Okay, fine. Kiran Kumar, right? Now we'll talk about some interesting question. We are building the block, right? Fine. Let's see that. Next question is coming in front of you, right? Fine. So what is the next question? In an orthogonal cutting operation, the depth of the cut is exactly equal to 2 mm. The width of a cut is exactly equal to 15 mm. Yes, Swati, Rajat, Naseem, right? Amir, everybody is correct, right? Cutting speed is exactly given 60 meter per minute and the rake angle is exactly given 0 degree, right? Fine. The cutting force and the thrust force are given 1200 and 800 Newton respectively, right? Fine. And the shear angle is exactly 30 degree, right? Fine. Now the question is coming, the first question, the average coefficient of friction between the chip and the tool. The average coefficient of friction, that means the mu value we have to calculate. Average coefficient of friction, mu value. Can we able to calculate coefficient of friction mu? Coefficient of friction mu, we have to calculate average coefficient of friction. Mu value has to be calculated, right? Aram se you have to segregate the data, then understand what exactly data is given, and based on that we have to revise that. Sir, can I say that whenever we are interested to calculate a coefficient of friction mu value, that means can I say friction angle beta has to be calculated? I know that simple story. What is that? Sir, if I want to calculate this, I'll simply write down, sir, mu whenever we are interested to calculate, which means that friction angle beta has to be calculated because we know that mu is exactly equal to tan beta. Mu is exactly equal to tan beta, right? Fine. Mu is equal to tan beta. And beta is exactly equal to tan inverse of mu. So if I calculate the friction angle beta by the given analysis, Kiran Kumar is very correct, right? By the given analysis, I can be able to calculate this value of this particular coefficient of friction B. So my idea has to be here, we first of all put our blood in the sweat to calculate friction angle beta, right? While calculating friction angle beta, sir, what is the data given? So you have to put that particular data in the systematic manner. So I'll write down, sir, depth of cut D and width of cut is given. So can I say that depth of cut D is exactly equal to, depth of cut is given. Let me, you know that, sir, depth of cut D is exactly equal to 2 millimeter. Depth of cut is exactly equal to what? 2 millimeter, right? Width of the cut, so I'll say that width of the cut B is exactly equal to 15 millimeter. Whatever data is given, cutting velocity VC is given 60 meter per minute, right? Fine. Orthogonal angle alpha 0 is given exactly 0 degree. Cutting force is given exactly equal to 1200 Newton, and thrust force is given exactly equal to 800 Newton, and shear plane angle phi is given exactly equal to 30 degree. So this is what exactly data is. This is what data is. Everybody please need to download the data first of all, and then you should think. So sir, if I'm interested to calculate the friction value, that is coefficient of friction, that is for that we have to calculate beta. And if you look into the data, you'll understand easily that, sir, cutting force and thrust force is given. And by Merchant's theory, we know that there is a relation between the respective forces done, right? And by that, can I say that there is a one master formula is tan of beta minus alpha 0. Can I say it is exactly equal to Ft divided by Fc? Do you know this formula? Thrust force divided by cutting force. The thrust force divided by cutting force is exactly tan of beta minus alpha 0. Tan of beta minus alpha 0. Sir, alpha 0 value is given 0 degree. So if I put 0 degree, I'll get directly tan of beta because that's the value I want to calculate. Even you can go and calculate beta value, and then that beta value can be utilized successively also, no worries. But directly I'll say that, sir, tan of beta is exactly equal to Ft divided by Fc, that is 800 divided by 1200. So can I say it is coming exactly 2 by 3? That is mu is exactly equal to 2 by 3. Mu is exactly 2 by 3. And even if we calculate beta value, sir, PPT मिलेगी? Yes, PPT मिलेगी, जिंदगी में मिलेगी, कोई दिक्कत नहीं है, रजित शर्मा, right? Absolutely correct. Yes, fine. So what is value of beta? If you know the beta value also, you tell me that. If you know the beta value, but don't require to calculate 2 by 3 is answer. So I'll say that, sir, 2 by 3 is answer. That's what exactly I require. This is what exactly answer is. Right? This is what exactly answer is. Are you accepting, everyone? Yes. Fine. Next question. Linked answer question is the cutting power in the watt. How to calculate power? Sir, cutting power? Power is very simple. How to calculate that? Sir, cutting force multiplied by cutting velocity. Fc multiplied by Vc. Fc multiplied by Vc. Cutting force. Fc multiplied by cutting velocity is nothing but called as cutting power. Right? Very important question. I have selected the question. Every basic fundamental should be get revised. Everything will calculate. Yes. Swati Kumari. Yes. Fine. So what is that? So I'll say that, sir, power. Cutting power is exactly equal to Fc into Vc. Fc into what? Vc. What is the cutting force? Sir, cutting force is given 1200 Newton. No worries. 1200 Newton, right? 1200 Newton. Multiply by cutting velocity. Sir, cutting velocity is given 60 meter per minute. But sir, if we calculate here, power has unit. What is the unit of power? Sir, unit of power is exactly equal to watt. Right? Watt is nothing but what? Watt is nothing but what? What is the unit of watt? Oh, sorry, power is exactly what? What is the unit of watt? Sir, Newton into meter, right? Joule per second is nothing but called as watt. Watt means what? Newton into meter divided by second. Newton into meter is what? Joule, right? Fine. So here force has to be in Newton, right? And can I say that multiply by this cutting velocity has to be meter per second. Most of the time students don't use that because meter per second is very important because Newton into meter is joule per second is watt. Rate of consumption of power, rate of consumption of energy is nothing but called as a power, rate of consumption. But it has to be considered with respect to second. And now here cutting velocity is given 60, that is meter per minute. Students use the same thing, that whatever per minute is there, it has to be converted per second. So can I say it has to be divided by 60? So it has to be divided by 60. So it will convert into what? Meter per second. And answer will be coming exactly equal to 1200 watt. 1200 watt. Is it correct, everybody? So this will be my answer. Are you accepting, everybody? 1200 watt. Flat 1200 watt. Right? Narajat and Amir B and Kiran Kumar. Very correct. Yes. Aptitude से हो जाएगा. Very correct. सलाम बॉम्बे, कोई दिक्कत नहीं. Fine. Now one more interesting question is there. Shubha Rustam hai. Calculate the length of the shear plane. Can you able to calculate length of the shear plane? Sir, length of the shear plane, if I talk about, this is the orthogonal view, 3D orthogonal view, tool is there, but tool I have cut. So can I say that this value will be called as uncut chip thickness T naught, right? This will be called as width of the chip B, or width of the cut B and W both are same here. And now this inclination is nothing but called as length of the shear plane. Called as what? Length of a shear plane, right? And that what exactly we are going to calculate, length of the shear plane LS value. An angle made by shear plane with cutting velocity vector is exactly equal to phi. So from this triangle, can I say that a tan of phi, oh, not tan of phi, I'll say that sin phi, can I say that sin phi is exactly equal to opposite, that is uncut chip thickness T naught divided by hypotenuse, that is a length of the shear plane LS. Length of the shear plane LS. So how to calculate length of the shear plane? Length of the shear plane, I'll take it left hand side. So T naught divided by sin phi. T naught divided by what? Sin phi. So how much is length of the shear plane? Anybody calculate length of the shear plane here? Length of the shear plane, sir, uncut chip thickness, what is that? What is that? Now sir, very important, we have to understand here. Most of the students are not understanding that. Let me tell you that. Sir, there are two values are given, if you understand, and there is one fundamental rule. Depth of cut is given and width of cut is given. Depth of cut is given and width of cut is given. And we know that there are certain fundamental rules that we have to follow while considering that. Sir, when depth of cut is given, can I say depth of cut will become uncut chip thickness T naught, right? And width of the cut will become width of the chip, that is what? B naught or W naught, that is exactly equal to 15 millimeter. Do you know that there are these fundamental rules as already discussed? Uncut chip thickness T naught will become 2, so that value we have to use it, and width of the cut or width of the chip, because width of the chip is considered to be remaining constant before, after and during the metal cutting operation. Before, after and during the metal cutting operation. Is it okay everybody? Kiran Kumar, it is 30, right? I don't know it's 30 or not. Let's check up that, right? Fine. So I'll say that T naught, what is T naught? 2 divided by sin of phi. What is the phi? I think so phi value is given 30 degree, right? Fine, right? Shear plane angle is given in the problem itself. So length of the shear plane is not coming 30 mm, not coming 30 mm. What is it coming? 4 mm. 4 mm it's coming. 4, sir. Are you accepting? 4 mm. Don't make a mistake. Don't make a mistake. Doesn't work. Doesn't matter, right? So I'll say that, sir, answer is 4 mm. This is my answer. This is my answer. Is it okay? Swati Kumar, Rajat, Naseem and Kiran Kumar, right? Yes. Okay, doesn't matter, doesn't matter. One more interesting question is coming. Let's see that now. How the question is coming. Very interesting question. Let's see that now. Now it's coming. A single point cutting tool with a 6-degree rake angle. Single point cutting tool with what? 6-degree rake angle is used for orthogonal machining operation of a ductile material. The shear plane for the theoretically minimum possible shear strain. If I want to generate the minimum shear strain, what is the condition and what is the formula that we have developed for minimum shear strain? For minimum shear strain to get generated, what will be the value of a shear plane angle phi? So we know that, sir, there is a third classical, I would say that rule is there in metal cutting operation to generate the minimum shear strain. To generate minimum shear strain, can I say that? Can I say that, sir? That is 2 phi minus alpha. That is exactly equal to 90 degree. This is the condition for what? Minimum shear strain. This is not a minimum energy. This is nothing but to generate the minimum shear strain. So minimum shear strain equation is 2 phi minus alpha is exactly equal to 90 degree. That is called as what? Minimum shear strain. Minimum shear strain to generate. Are you accepting everybody? Yes, Kiran Kumar, very correct. So minimum shear strain, phi is nothing but shear plane angle phi, alpha 0 is rake angle, 90 degree is the number, and we are knowing that, sir, alpha 0 is given 6 degree. So I'll say that 2 phi minus 6 degree is exactly equal to 90 degree. So phi value is coming exactly equal to 48 degree. 48 degree. Are you accepting everybody? 48 degrees correct answer. 48 degrees correct answer. Sandeep Reddy, is it true? Yes, yes sir. Now we have started moving towards interesting question, right? Now we are building some blocks. Now we have developed some fundamentals. Already fundamentals are there in your body. No worries, right? Fine. Here it comes the next question. In an orthogonal machining operation, right? In an orthogonal machining experiment using a tool having 6-degree rake angle, following data is collected. Now, what is the data collected? Right, fine. Cutting speed is 60 meter per minute. Width of cut, very correct. Amar and Rajat Mishra, Swati, right, fine. Very correct. Cutting speed is 60 meter per minute, right? 60 meter per minute. Width of the cut is given 3 mm. Depth of cut is also given 1 mm. Please understand that what is depth of cut, what is width of cut, uncut chip thickness, width of the chip. Very important to understand answer for us. Right, fine. Chip thickness is also given 1.5 mm. Assume that the shearing takes place under minimum energy condition. Now there is what? Minimum energy condition is coming. Right, fine. And the coefficient of friction between tool and the chip interface. Coefficient of friction between tool and the chip. When the chip is flowing over the next surface. So what will be that coefficient of friction? Mu under minimum energy condition. And we know that there is a one minimum energy condition as far as merchants is concerned. And there is what? Merchants minimum energy condition. There is one formula is also there. With the help of that, we have to calculate answer. What is the value of mu? Can we be able to calculate? Very interesting. We have to apply what? Merchants minimum energy condition. Point to be understood. Merchants minimum energy condition has to be used. Can we be able to calculate somewhere? BYJU'S Exam Prep, right? One of the scintillating platform. Please download the app, join, and let all the participants, all the GATE examination participants to be aware that this is what exactly happening. And we know that, sir, please point to be understand in 1 hour we have a lot of limitations. How many things we can teach you in 1 hour? That's what basically the problem is, right? Point. But still we are trying our best to deliver the best of the things. Kiran Kumar, what happens? Sir, whatever the data is there, let me check that. What is the data is there? And the data has to be, let me check that because all the calculations are there. So whatever value is given, I'll try to write down this value. It cannot be written here. So in the next slide, I'll try to write down. I think so you have noted down all the values, right? Fine. So what is the values there? So value is very simple. Sir, orthogonal rectangle alpha 0 is given exactly equal to 6 degree. Cutting velocity VC is given exactly equal to 60 meter per minute, right? 60 meter per minute. Okay, fine. Width of the chip B is given exactly equal to a 3 millimeter. What is that? 3 millimeter? Nothing to worry. 3 millimeter width of the chip is given. Depth of cut D is given 1 millimeter. Right, fine. Chip thickness ratio TC is given exactly equal to 1.5. I'm just writing down whatever the data is given. I'm just writing down, and then we'll come across. Rajat Misra C. Let me check what is the answer. Right? I don't think so, Nasim Khan. That is what answer is. I don't think so. Let's check it out. Right, fine. Now, minimum energy condition. You tell me that what is the minimum energy condition for merchants? Sir, merchant has developed one equation. It is called as merchant's equation for minimum energy, and that is very famous. That is nothing but called as what? Sir, 2 phi plus beta minus rectangle alpha 0 should be exactly 90 degree. Is it the merchant minimum energy equation? Yes. And we know that we are interested to calculate coefficient of friction mu. That means by default we have to calculate what? I told you that calculation of mu is nothing but calculation of beta, because there is a relation. So with the help of merchant's minimum energy equation, we have to calculate the value of beta, that is friction angle beta. Then once you calculate beta, we'll get the coefficient of friction mu. That's what simple journey is. That's what 0.47. I think so Kiran Kumar is very correct. Now you are on the right track, Kiran Kumar. Super, right? So we have to calculate beta. For calculation of beta from this equation, can I say that, sir, we have to require phi value and alpha. Sir, alpha 0 is there already. Alpha 0 is already given in the problem. Then we require phi. And for calculation of phi, sir, there is a scintillating equation for calculation of phi. That is what? Sir, tan of phi is exactly equal to R into cos of alpha 0. R into what? Cos of a alpha 0. R into cos of alpha 0 divided by what? 1 minus R into a sine of alpha 0. Right, fine. What is meant by R? R is chip thickness ratio. And I'll say that R is chip thickness ratio T0 divided by TC. How to calculate that? It will be exactly equal to uncut chip thickness divided by thickness of the chip. Right, fine. Now, what is uncut chip thickness? That's a $1 million question is coming. What is uncut chip thickness? Sir, here chip thickness is given and there are two values given. Width of the chip and depth of cut. Can I say depth of cut will become uncut chip thickness by default here? So therefore depth of cut will become uncut chip thickness. It will become crystal clear now for everyone. Crystal clear, Swati Kumari, perfect. So R is equal to T0. T0 is 1. TC 1.5. What is chip thickness ratio R? I think so R value is coming. I don't know what is value. 0.667. This is what exactly chip thickness ratio is there. You put it here. Alpha value is 6 degree. Chip thickness ratio R is there. You will get a phi value. If I am not wrong, this phi value is coming exactly equal to 35.44 degree. 35.44 degree. Now you put it here. If I put here, I'll get the value of beta. So value of beta is coming what? 25.10 degree. 25.10 degree. This is what exactly value is coming. And then I require to calculate what mu. So can I say mu is exactly equal to tan beta, right? Tan of beta, tan of 25.10. So mu value is coming 0.468. 0.468. Balle balle. Right, Pooja Kumari, good evening. Are you accepting everybody? Yes, mu value is coming this one. So this is the way we have to tackle, because measure cutting problems are such that first of all it feels that key I don't understand. So write down data, write down formulas, do something, you'll get the answer. I don't have any problem. So value is what exactly? Calculate as C is exactly equal to answer. Are you kicking and alive? Everybody is kicking and alive, right? Fine. One more now. We are going in a forward direction now. Interesting question is waiting for you. Sir, area of the shear plane. Sir, I don't tell you anything. Area of the shear plane is very, very simple. Let's not waste valuable time. We know that. What is the area of shear plane? Can I say whatever the area it is at shear, this is the area of the shear plane. So if the area of the shear plane, length of the shear plane multiply by width of the chip, that can be considered as B naught, because we know that width of the chip before, during and after the measuring operation remain constant. So can I say that the area of the shear plane AS is exactly equal to B naught multiplied by length of the shear plane LS. Length of what? Shear plane LS. There is no problem at all. Right? Fine. Is it true? So you can be able to calculate that. I don't have any problem. I'll tell you that answer is coming, AS is coming 5.2 millimeter. 5.2 millimeter, because already one type of this question is calculated. So you can be able to calculate length of shear plane, and the B naught, that is width of the chip. Width of the cut is given, width of the chip is given in the problem. Just you can calculate. Swati Kumari, what is that? C, absolutely correct. Thumbs up. Right? We are not interested to waste now. Same numericals we don't interested to calculate. Right? Now this is very interesting question. Very interesting question. If you are able to solve that, thumbs up. Very interesting question. What is it? Let's see. A seamless, understand very well. A seamless tube. A tube is there. A seamless tube of 32 mm outside diameter is turned on the lathe machine. So turning operation is done on the lathe machine. The cutting velocity of the tool relative to the workpiece is 10 meter per minute, which means that cutting velocity of the tool with respect to workpiece, it is VC. The rectangle is 35 degree, depth of cut is 0.125 mm, length of the chip, understand, length of the chip is given 60 mm, horizontal cutting force is 200 Newton, vertical cutting force is 80 Newton, and we know that vertical cutting force is always cutting force, and horizontal cutting force is always what? Thrust force. 1.52, oh my God. Your words are penetrating my heart like a demon, man. Kiran Kumar, friction value cannot be greater than 1 generally. And if the friction value is greater than 1, it's coming you to apply what? Classical friction theorem. You must have heard. That's also called as Cronenberg's equation. Cronenberg's equation has to be taken out from the pocket. It has to be taken out from the pocket. That's why I've taken this question. Very interesting question. Write on the data. Yes? Yes, Kiran Kumar? Yes. Right? बुलाती है मगर जाने का नहीं, बुलाती है मगर what? जाने का नहीं, बस. Sir, Leko, this is what data is there. I'll write down data. Data I'll write down. I fall in love with the data. What is the seamless tube of outside diameter D naught, 32 millimeter. Right, fine. Cutting velocity VC is exactly equal to 10 meter per minute. Rectangle alpha 0. Rectangle alpha 0. Rajat Mishra boy. Absolutely correct. 0.54. Spot on. Love you. Right, fine. So alpha 0, rectangle. What is alpha? 35 degree. Okay, superb. 35 degree. DA, depth of cut 0.125 mm. Length of the chip, LC, length of the chip 60 mm. Thrust force, understand that 200 Newton. Horizontal cutting force is always thrust force. Horizontal cutting force is always thrust force, and vertical cutting force is always the cutting force FC. Right, super Nasim. Right, fine. 80 Newton. Right. Now there is one Cronenberg's equation. Cronenberg's equation tells that mu is exactly equal to ln 1 by r divided by pi by 2 minus alpha 0. Divided by what? Pi by 2 minus alpha 0. Pi by 2 minus alpha 0. Whenever the friction value by the conventional way, tan of beta minus alpha 0. इसका फॉर्मूला याद नहीं आ रहा. It is nothing but called as Cronenberg's equation. Whenever by conventional way, that is tan of beta minus alpha 0 is equal to ft by st. When it is coming in the picture, then we have to use this. So point to be understand here. Generally, you tell me that which force has to be greater? Cutting force has to be greater than the thrust force. My dear, good lord. And here, if you understand that cutting force is less than the thrust force, cutting force is less than thrust force. So generally, when the cutting force becomes less than the thrust force, my friction value becomes greater than 1 by the conventional way, and therefore here Cronenberg's equation I have to use. So alpha 0 is given in the problem. I have to calculate chip thickness ratio R. If I calculate chip thickness ratio, I'll put it there and I will do balle, right? प्रोडक्शन के शॉर्ट नोट्स मिलेगी, या प्रोडक्शन का सब मिलेगा यहाँ पे. दिस इज द प्रोडक्शन, आई वुड से दैट पावर हाउस ऑफ प्रोडक्शन. You'll get everything because there are only two things in my blood, I think so. One is hemoglobin and second is production, because then 10 years I did the same thing. I don't understand anything on the life, so you'll get everything, don't worry. Yes, fine, nothing to worry about it, right? In seeing this formula for first time, no, Kiran Kumar, you should not say like that. When you downloaded my notes and when you go through that notes, you'll understand that. Hello Harshit, you understand that, sir, there is one formula, acronym burst, you please go and check it that. Please Kiran Kumar, you go and check it that. Right, fine. So chip thickness ratio, boss, what is chip thickness ratio?Ir, chip thickness ratio, there are so many formulas, but sir, length of the chip is given. So therefore, there is one beautiful formula, L0 by LC. Sorry, LC by L0. Can I say length of the chip divided by original length L0. This is chip thickness ratio. This is chip thickness ratio. Is it true? LC by L0. LC by T0 by TC, like that LC by L0. What is LC? Length of the chip. What is L0? So if there is a cylindrical body, very cylindrical body, if there is cylindrical body, right, please to understand, whenever I am touching to the tool and there is a turning operation, see in one rotation, how much will be uncut length of the chip? How much will be uncut length of the chip? And therefore it can be expressed in this manner. If this is my tube, and this is my tool which is engaged here. This is my tool. Single point cutting tool is engaged here at this particular moment. If this is engaged like that, so can I say that in one rotation, how much is the uncut length? How much is the uncut length? Can I say uncut length is exactly equal to pi d? That is what exactly length of the chip is going to get cut. Length of the uncut chip, right? Production में formula बहुत है sir. Short notes सी exam में बचाएंगे. Yes. Short notes मिलेंगे. I am working on it and very shortly, yes, I'll just come out with these particular things. Right, fine. Uncut chip thickness, you understand that? Yes, chip thickness ratio is LC, that is 60, divided by uncut chip thickness, that is pi d, diameter 32, and that is what the reason these values are given. So chip thickness ratio R is coming what? I don't know what is value of coming, and my notes are scattered here. Okay, 0.596 is coming. Yes, you put all the value here. Mu value is coming 0.54. 0.54. Is it coming? Yes, 0.54. 0.54. 0.54. I hope you are understanding. 0.54. That will be my answer. Is it okay? Yes. Yes, fine. Super. One more question. Scintillating questions are waiting for you. Right, fine. What is it? Beautiful. Dekho, one more concept is there in front of you. One more beautiful concept is there, right? Why to care when I'm there, right? Fine. Right, next. During orthogonal machining operation with a rake angle of 10 degree and uncut chip thickness is 0.125, the values of FC and FT, cutting force and thrust force, are given 517 and 217 respectively. Average chip thickness is also measured and found to be 0.43. Okay, fine. Machining constant for the work material is. Machining constant we have to calculate now. Multiple buffet laga yahan pe. We are talking about so many variety of questions. What is machining constant? Kiran Kumar, Archit Swati and rest of all the students. And tell everyone that we are solving very beautiful questions so that they'll also participate. If someone is willing to undergo some variety of questions, this is the place. Please share that. And all the rest of the sessions are also going in a so fantastic manner. We believe in content. We believe in what? Delivering the best of the content. Right, fine. Sir, machining constant, you tell me that. What is machining constant? Sir, machining constant, I know that, sir. CM is machining constant. That is 2 phi plus beta minus alpha 0 is exactly to machining constant. Yes, machining constant 2 phi plus beta minus alpha 0. Right? Yes, Swati Kumari, super. Yes. 2 phi plus beta minus alpha 0, which means that I have to put a value of phi, beta and alpha 0. Summation of that will get a machining constant, and that machining constant is also taken from where? Merchant's analysis for minimum energy. Thumbs up. Right, fine. So what is the data given? Based on the data, I'll write down the number of things. Sir, rake angle is alpha 0, that is exactly 10 degree. Right, fine. 10 degree rake angle is okay, fine. Then uncut chip thickness T0 is 0.125 millimeter. Very interesting question. 0.125 millimeter. No worries. 0.125 millimeter, sir. Okay, super. Then there is cutting force and thrust force is given, sir. FC is exactly equal to 517 Newton. Okay. FT is exactly equal to thrust force is exactly equal to 217 Newton. Right. Chip thickness TC is exactly 0.43 mm. Right. Machining constant we are interested to calculate. So alpha 0 ka kaam ho gaya, come on. Alpha 0 is there. Alpha 0 is there. Right, fine. Now beta value I have to calculate and the phi value I have to calculate. Beta value and the phi value. Sir, beta and the phi value, sir, I know that from the Merchant's equation, I know that. So Merchant's minimum energy equation or Merchant's force, Merchant's circle diagram, Merchant's force analysis, tan of beta minus alpha 0 is exactly equal to Ft divided by Fc. Do I know this formula? Ft divided by Fc. Tan of beta minus alpha 0. Alpha 0 I know that. Ft I know that. Fc I know that. Can I be able to calculate beta? Yes, I can be able to calculate beta from here. That's the point, right? So I'll write down, sir, here tan of what is beta? Sir, we have to calculate. What is alpha 0? 10 degree is exactly equal to Ft by Fc. What is Ft? Sir, thrust force is 217 Newton divided by Fc. How much is Fc? How much is Fc is coming? Right? How much is Fc is coming? So I know that, sir, Fc is exactly equal to 517. So beta value is coming exactly equal to, if it is there with me, beta minus alpha 0. Sir, do I require to calculate this value of this? I would say that beta actually, so let it be beta minus alpha 0, no? Because it is there, beta minus alpha 0, so we don't require. So I'll directly say beta minus alpha 0. Don't put the value of alpha 0 there. So beta minus alpha 0 is coming 22.76 degree. Let it be there. Let it be like that. Let it be like that. Right? We'll solve that. Sir, phi. Why to calculate phi? Sir, calculation of phi is very simple. Till now, number of times we have discussed that tan phi is exactly equal to R into cos of alpha 0 divided by 1 minus R into sine of alpha 0. So chip thickness ratio T naught by TC. T naught by what? TC. If I come back here, what is the value of T naught? T naught is given. What is the TCRA? Both values are given, boss. Right, fine. So I'll say T naught by TC. So T naught value uncut chip thickness is there, 0.125 divided by 0.43. So R value is coming 0.290. Right, to 0.290. I hope you are calculating this, right? 56 point. Kiran Kumar, absolutely spot on, boss. Now I'm checking, it's correct. So I'll put value here, tan of phi is equal to R 0.29 into cos of alpha 0, that is the 10 degree, if I'm not wrong, divided by 1 minus 0.29 into sine of 10 degree. Sine of what? 10 degree. So phi value is coming exactly equal to 16.74 degree. 16.74 degree. And therefore I'll say that, sir, machining constant is equal to 2 into phi, that is 16.74 degree, plus beta minus alpha 0, and beta minus alpha 0 is 22.76 degree. So machining constant is coming exactly equal to 56.24 degree. 66.24 degree. Yes. Swati Kumar, it's not 16. 16 is not correct. 16.74. Yeah, that's what. Correct. Phi value is 16. Right, fine. You might be calculating something, right? Fine. So my answer is exactly equal to this one. Let's say how diversified background questions we are solving. Right, everyone? Yes. Again, very interesting question is coming, right, fine. And that interesting question is there in front of you, right, fine. Let me check that what interesting question is there, right. Again, you need to understand that. These questions are very lengthy questions, right, fine. In an orthogonal turning of a bar of 100 mm diameter, there is one bar of 100 mm diameter with a feed of 0.25 mm per revolution. Feed is given. The depth of cut is 4 mm and the cutting velocity is 90 meter per minute. It is, observe that the main cutting force is perpendicular to the friction force at the tool chip interface. Main cutting force Fc is normal to the friction force. The main cutting and tangential force is 1500 Newton. Main cutting and tangential force is what? 1500 Newton. The orthogonal rake angle of the cutting tool is in degree. Sir, TPM, sir, how to attempt DRDO scientist B mains questions? Please give the tips for numericals and theoretical questions. Let's see that. I have segregated the previous year DRDO questions and I checked that DRDO questions also. Let me tell you a simple story. There are very basic fundamental questions are asked where calculations are less. And very fundamental questions based on GATE examination only, but fundamental questions are asked. If you go and solve these previous year questions, I'm damn sure that you'll prepare yourself in a much better manner to appear for DRDO examination. 3.58. 3.58. My heart is penetrating like a demon. Naseem, it's not correct. Kiran Kumar, understand the statements and tell me answer. Understand the statement in the gravity. Sir, can I say that cutting force is the normal to the friction force? So if I draw a friction angle, can I say that, sir, horizontal, this is my cutting force? Can I say this is my cutting force, this is my cutting force, this is my cutting force? Isn't it cutting force? Yes. So I'll say that, sir, this my cutting force FC is normal to a friction force. Normal to friction force. So can I say that this will be my friction force FC, or friction force is called as Fs. Are you accepting, everybody? Friction force Fs. Friction force is acting what? Friction force is acting in reverse direction, right? If I talk about here, my friction force, when the chip is flowing, it is resisting. This is friction force. This is what exactly equal to friction force Fs, and there will be a normal to friction force that is exactly equal to Fn, right? Friction force and normal force. It can be rewritten as F and N also. I can say that F is a friction force, N is a normal force. My friction force is normal to friction force is normal to cutting force, or cutting force is normal to friction force. When that friction force can be normal to cutting force, what is the orthogonal rake angle of this tool? Orthogonal rake angle alpha 0 is exactly equal to 0 degree. If my tool is not a 0 degree rake angle, if my orthogonal rake angle of the tool is not a 0 degree, is it possible to normal that cutting force to that particular friction force? Is it possible? No. So can I say that it has to be what? 0 degree? Amir and Kiran, you are understanding that very correctly. So can I say that, sir, my answer is 0 degree. 0 degree. Dekho, do I require to calculate anything? This is get examined. Fundamental. Cutting force normal to friction force only in that case. Right, fine. Now, sir, if I want to complete this, right, fine, I'll say that this horizontal force, if I draw the horizontal force now, can I say that here, without any doubt, can I say that it will be exactly equal to my normal force, right? Normal force, right, fine. Now, can I say if I draw the vertical line here, can I say that it will be exactly equal to my thrust force Ft, right? This will be exactly equal to my resultant force R, right? When the alpha 0 is 0, when the rake angle of the tool is alpha 0, 0, there are certain takeaways you have to take. What are the takeaways? Direct result yaad hai. Very correct. What is the takeaway? Can I say that, sir, cutting force Fc is exactly equal to normal force N, and friction force F is exactly equal to thrust force Ft. Are you accepting this? Beautiful thing, and you love that, right? Fine. खाली गर्लफ्रेंड को लव नहीं करना है सर. लव आर ऑफ डिफरेंट काइंड. लव योर सब्जेक्ट, लव योर प्रिपरेशन, लव द जर्नी, एंजॉय द जर्नी. आई होप यू आर अंडरस्टैंडिंग दिस, राइट? Understand that? Yes. Next question. Based on same data, there is one beautiful question. The normal component at cheap tool interface. Normal component at cheap tool interface in what? Newton. Which means we are interested to calculate a normal force. We are interested to calculate what? Normal force. We are interested to calculate normal force. Right? Fine. If the same question, normal force. So, sir, can I say that my normal force is exactly equal to cutting force? Normal force is exactly equal to cutting force. Yes. How much is the cutting force? Sir, it is given main cutting force is 1500 Newton. So I'll say that, sir, main cutting force Fc is 1500 Newton. 1500 Newton. So can I say that normal force will be also same thing? Normal force will be also same thing. Normal force will be also same thing. Right? Fine. Normal force will be also same. So I'll say that, sir, कितना आएगा भैया? 1500. C is exactly equal to answer. Understand the things very, very deep. Right. Kiran Kumar, correct. 1500 Newton. Bombay Bees, correct answer. Bombay Bees, correct answer. One more interesting question is coming in front of you. Beautiful. Epitome of question. During turning operation, the specific work material having the shear strength of 220 megapascal. Under the orthogonal cutting condition, the process parameters are given. Speed is given, depth of cut is given, rake angle is given, negative rake angle. And the rake angle can be negative. There is no big deal. Rake angle can be positive, rake angle can be 0, rake angle can be also negative. Right? Given the chip thickness ratio is 0.5 chip thickness ratio is given 0.5, friction angle is given 49.2 degree, and the shear angle is given 25.4 degree. The feed force in Newton, feed force in the Newton, right? Calculate the feed force in the Newton. I'll just check it that. Where is the feed force? So it's a very lengthy question, by the way. It's very lengthy question. Feed force means what? Can I say the thrust force? Can I say feed force is exactly, there are two forces coming, cutting force and thrust force. So can I say that we are interested to calculate the feed force? Can I say that we are interested to calculate feed force? That means I'll say that, sir, we have to calculate the thrust force. And if I say that feed force, that force has to be acting along the feed direction. Whenever the tool is moving, I hope you are understanding the feed direction. So can I say that if the thrust force has to be exactly equal to feed force, and that is only possible when the approach angle lambda has to be 90 degree, and or can I say that side cutting edge angle CS has to be 0 degree. Fundamental, boss. It cannot be learned in one day. It cannot be learned in 1 minute or 1 hour. There has to be a dedication of at least 20 to 25 hours you have to give an understanding of this what entire philosophy, ESE system of tool geometry, orthogonal system of tool geometry, how ESE is converted to RS, how angles are coming, right? Yeah, dekho, now there are so many people are coming for their campaigning also. This is the open world, right? You do campaign whatever you want, right? Fine, no worries. So are you understanding this? What exactly I'm talking about? Yes. So I'll give the solution how exactly it is. So can I say that we have to assume that? So this particular way I'll say that, sir, this is side cutting edge angle is exactly 0 degree, or approach angle lambda is exactly equal to 90 degree. So this is the approach angle lambda is exactly equal to 90 degree. Right, fine. This is what exactly my thrust force. Can I say that thrust force will be like this? This is exactly equal to thrust force Ft, and that is nothing but called as this Ft is nothing but called as what? My feed force. Is nothing but what? Feed force. Feed force. Are you accepting, everybody? Yes, feed force. That is what the way by which we have to calculate feed force. Now, if I want to calculate the thrust force, 711 Newton, Kiran Kumar, I don't think so. That is answer. Now, if I want to calculate this force, that thrust force can be calculated by Merchant's equation. That is nothing but, sir, Merchant's analysis. That is Merchant circle diagram. Merchant circle diagram is utilized to correlate with the measurable forces with the actual forces. Thrust force and cutting force are measurable forces, and actual force are what? The shear force and normal to shear force, friction force and normal to friction force. And from that, if you compare that, you know that shear force divided by Fs from the Merchant circle diagram, if you remember, shear force Fs divided by a cos of phi plus beta minus alpha 0 is exactly equal to cutting force Fc, or I'll say that's the thrust force Ft divided by what? Sine of beta minus alpha 0. Sine of what? Beta minus alpha 0. And why we are selecting this data, I'll tell you that, because if you talk about data, what is the data, sir? Shear stress is given 220 megapascal. Shear stress is given what? 220 megapascal. Time is very come. Depth of cut is given 1 millimeter. Right. Feed is given 0.2 mm per revolution. 0.2 mm per revolution. Alpha 0 backrack angle. No worries, sir. Minus 5 degrees. कोई दिक्कत नहीं है. Let it be minus 5 degree. Chip thickness ratio R is also given 0.5. Friction angle beta is given 49.2 degree, right? Fine. Shear plane angle phi is also given 25.4 degree, 25.4 degree, right? Sir, beautifully cutting force is not given. Cutting force is not given. So if my shear stress is given, so can I say shear force can be calculated? Shear stress is given, so shear force can be calculated. So can I say that, sir, shear stress is exactly equal to shear force Fs divided by shear area, and shear area already we have discussed how to calculate that. So therefore I selected thrust force we are interested to calculate. Then there is only one way, that thrust force has to be compared to the shear force with the help of Merchant circle diagram. With the help of what? Merchant circle diagram. Shear force and thrust force can we get? Yes. That's what exactly we are talking about, the same story. And now if I want to calculate the shear force, then we have to calculate shear area, and then shear area multiplied by shear stress will go to the shear force. Are you accepting? Yes. So therefore I'll say that, sir, I know that shear stress is exactly equal, or from here I'll say that, sir, shear force is exactly equal to shear stress multiplied by shear area, and shear area is T naught into W divided by sine phi. T naught into W divided by what? Sine phi. Right? Fine. Now this is big lengthy question is coming, no worries. From there shear force is coming directly. I'll write down 102.58 Newton. No, Kiran Kumar, that is not also answer. Shear force is coming 102.58 Newton. Right, fine. Don't worry, that is not answer. Right, fine. Answer, can I say that here, if these values are given, uncut chip thickness T0 will be exactly depth of cut, that is 1 millimeter. Right, is what exactly? Right, fine. And the width of the cut is exactly equal to width of the chip. So uncut chip thickness is not this. I know that, sir. Uncut chip thickness should be a feed, and depth of cut will become exactly equal to width of the chip, or this. So this is 1 millimeter, and this feed is exactly equal to 0.2 mm. Now most of the students will ask me that, but sir, you need to understand that there are three different cases we have developed. What is that? And if you don't understand that, I have delivered one note, and that is nothing but notes are uploaded in my Telegram channel. You can go and watch there that notes. What is that? When the feed is given and depth of cut is given, my feed becomes uncut chip thickness, and my depth of cut will become exactly equal to width of the chip. My depth of cut will become exactly equal to width of the chip, or width of the chip which comes in the picture. That's what. So therefore, and anyway lambda is 90 degree. So these values are there. I hope you are understanding that. Yeah, 460. Kiran Kumar, now you got it the correct answer. Right, fine. And now I'll put the value of phi beta alpha 0. All the values are there, I think so. Right, fine. Phi beta alpha 0 is there. And now I'll say that, sir, thrust force is coming exactly equal to 460.892. 460.892 Newton. 460.892 Newton. That is what exactly my answer is coming. Yes. You remember arts for you, correct? You remember that? Yes, and that's what we want. That is what we want. Right. So many questions are there, my dear friend. Right, fine. Now this is very simple question, right? But still it was asked in 2020, so I'll ask you that. Okay, what is it? What is this question is? Calculate the shear plane angle. In turning process, in what turning process? Using the orthogonal tool geometry, a chip length of 100 mm is obtained for an uncut chip thickness of 250 mm. Uncut chip thickness of what? 250 mm. Sorry, not uncut chip length. It's not chip thickness, it's uncut chip length. The cutting conditions are given. The cutting speed is 30 meters per minute. Rect angle of the tool is given 20 degree. The shear plane angle is. What is that? Shear plane angle we are interested to calculate. So can you able to calculate shear plane angle? Can you able to calculate a shear plane angle here? Can you able to calculate shear plane angle? Anyone? So sir, what is the data given? I'll just write down the data. What is big deal? Right, fine. What is big deal? So sir, it is given that length of the chip is given 100 mm, right? Right, 100 mm is given length of the chip. And length of the uncut chip L0 is given 250 mm, right? Instead of uncut chip thickness, length is given, but we know that, right? What is answer is coming 23? Kya baat hai? Right? Kiran, Amir, everybody correct answer, right? Fine. The cutting velocity is given 30 meter per minute, right? But it is not required at all. And here I'll say that, sir, alpha 0 is given. How much it is? 20 degrees given. And we are interested to calculate shear plane angle phi. So calculation of shear plane angle phi, we have a simple equation. What is that? Tan phi is exactly equal to r into cos of alpha 0 divided by 1 minus r into sine of alpha 0, 1 minus r into sine of alpha 0. Now r value we are interested to calculate. So can I say r value is exactly equal to length of a chip divided by this one, LC divided by L0. Is it accepted, everybody? LC divided by L0, right? Fine. T0 by TC, LC by L0. What is LC? 100. L0 is exactly 250. So chip thickness is coming 0.4. And if I put here, I'll get the phi value. It is coming 23.53 degree. 23.53 degree. That is what exactly my answer is coming. Is there any doubt, Kiran Kumar? Yes. Right. You are calculating correct answer. No worries. Right. Fine. And then we are not solving this question. Let it be. Right, fine. So we'll solve this question, and that is what exactly I'll say that is interesting one. What is that? During orthogonal machining of the job, during what? Orthogonal machining of the job at a cutting speed of 90 meter per minute with a tool of 10 degree rect angle, The cutting force and the thrust force are given respectively 350 Newton and 390 Newton. Okay, fine. Assume a shear plane angle of 35 degree. The power, that is what rate of consumption of energy. Power, that is what exactly rate of consumption of energy that is extended for shearing along the shear plane. Shearing along the shear plane. So we are interested to calculate power only along the shearing operation. Only along what? Shearing operation. Can we be able to calculate? Power only along shearing, not the total power. Shearing power. It can be considered what? Shearing power. Power of a shearing operation. So can I say that shearing power is nothing but what is the power? Cutting force multiplied by velocity. FC multiplied by VC will give you total power. But we are not interested to calculate total power. I am interested to calculate what? I am interested to calculate very interestingly shearing power. That means can I say that shear force multiplied by shear velocity? Shear force multiplied by shear velocity. Yes, that is what exactly we are interested to calculate. Shear force multiplied by shear velocity. Right? Kiran Kumar is dedicated student and he solves number of numericals. And whenever he comes, he gives generally correct answers. Right? So what is the data is given? Sir, I'll write down data. Cutting velocity is given 90 meter per minute. 90 meter per minute. Right, fine. And alpha 0 is exactly equal to 10 degree. Right, fine. Cutting force FC is exactly equal to 750 Newton. Right. Thrust force is given exactly equal to 390 Newton. And phi value is given exactly equal to 35 degree. Phi value is given what? 35 degree. That is what phi value. Power of shearing operation. So shear force multiplied by shear velocity. Right, fine. Now I'll give you a hint here and will not solve the entire question. Right, fine. So shear force can be calculated based on a one relation, that is cutting force into what? Cos phi minus a thrust force Ft into sin phi, because cutting force is given and thrust force is given, shear plane angle phi is given, and based on the force analysis you must understand that shear force is equal to cutting force into cos of phi minus Ft into sin phi. So you can calculate shear force. Shear force value will get exactly equal to 390.66 Newton. 390.66 Newton. And shear velocity has to be calculated, that is velocity of shear plane along, or velocity of the chip along the shear plane, that is shear velocity, and that has to be calculated based on a velocity triangle. And from that, the velocity triangle say the shear velocity Vs is coming 97.79 meter per minute. What is the answer is coming? Meter per minute. That is what exactly a shear velocity is coming, and therefore a shearing power is coming. Right, shearing power. Please convert that to the meter per second. Meter per second you have to convert. Meter per second. Shearing power is nothing but Fc into Vs. That is shear force multiplied by shear velocity. It is coming 639.72 watt. This is my answer. Right, fine. This is my answer. So I think so I could be able to take number of questions and variety of questions we have solved. Number of things we have discussed, how to calculate basic fundamentals. Still in the metal cutting there are so many topics. Machining economics is there, then the tool life is there, right? These are the two important. Then the machining process, how exactly surface finishes depending upon the cutting force and thrust force, as well as the tool geometry. That is also number of questions are there. Right, fine. So I will thank all the participants, all the learners to join this platform. So again we'll have one more session on the 25th. Today is 23. One more gap is there tomorrow. Day after tomorrow again we'll meet next topic. Again same particular 20 questions or 25 questions, best of the possible, where you will get a diversified background and understanding of things can be able to cover. And I'll share this particular PDF of this particular in my Telegram channel. As well as we'll share at the BYJU'S Exam Prep also. So you can join the BYJU'S Exam Prep Telegram channel as well as my Telegram channel, so that you will get benefited from the initiative that we have taken. Is it okay, everybody? So thanks all the participants. Take care of yourself, mental and physical health. Continue your preparation and the journey, because we know that, sir, Rome cannot be built in one day. It has to be number of days required, number of months are required, constant efforts are required to get success. Right? Believe in yourself. Right? That's the most important thing. Keep playing, keep believing, keep walking. All the best. See you in the next session, folks. Thank you, everybody.